Hey there, basic algebra. This is Mr. Graves here. When we last left off, so before our break, when we last left off, we were working on graphing. Sorry, I had the wrong thing pulled up there. We were working on graphing quadratic equations using standard form. Now, looking at number 5 here, let me pull this laser pointer up. On number 5, we were able to factor to find the zeros of our quadratic, so where our quadratic crosses through the zero of our x-axis, so where it crosses through our x-axis, at 2 and 6. And so we did that by factoring. We have to set those factors to equal to 0 to find the zeros, and then we solved and we got this mess here, and that's where I was able to get my purple points. I know it's been a while since we've looked at this. We also found our vertex of 4 and negative 4, and we were able to graph that. And so that was one of the ways we did it, by factoring. And based on the question at the end of the video last time was, which way do you prefer? And it was about half and half. Some people, about half the class, prefers doing the factoring. The problem with factoring is that there's not always zeros that it goes through. You may get some problems that don't have zeros, and then factoring does not work, and that's where we see that there. In fact, this does have zeros on number 6, but they're not clean. It's not going exactly through 3 or through 2.5 or anything like that. And we knew that from, I know it's scratched out here, maybe this will erase, but we see that because we weren't able to factor it. And so what we did instead was, and this was the other way that we could solve these, we find our axis of symmetry, or our vertex, sorry, we find our vertex using negative b over 2 times a. We plug that in, and we find our vertex, and our vertex is our middle point. And we choose a point 1 away from our middle and a point 2 away from our middle. So it's 1 away, that's 2 away, and they reflect going this way. And then we just solve for each one of those. So that was what we worked on last time. Just as a reminder, I'm going to show you how we graph in vertex form, just as a reminder. So down here I have vertex form, and I'm going to show you how to graph here and on number 2, and then we're going to take a look at solving for zeros in vertex form. So when we find the zeros in standard form, it was by factoring. We had to do this big X, we fill it out, we get our numbers, we set it equal to 0, those are our zeros. The process is a little bit different for vertex form. So we're going to take a look here at number 2. And these were things that, if you were in my class last semester, we worked on this. We know that our vertex equals, it's going to be the opposite of the inside number, so a positive 2. And then it's the same as our outside number, which is also a positive 2. So our vertex is 2, 2. And we could plot that. So 2, 2 would be 1, 2, 1, 2, and that's going to be right up here. So there's my vertex. And then what we did last time to graph this was we would, remember we said we could find the y-intercept. So that means if x is 0, if our x was 0, what do we get for y? And so we could fill out our equation. I'm going to use blue. We take our original equation and we say y equals negative 2 times, well, if x is 0, we'll just say 0 minus 2 squared plus 2. And then y equals negative 2. Inside my parentheses, 0 minus 2 is negative 2. Lots of 2's going on this problem. And then we follow our order of operations. So y equals negative 2 times 2 to the second power. Negative 2 times negative 2 makes a positive 4. So I'm going to put a 4 here. Then I'm going to work my multiplication out. So y equals negative 8 plus 2. And that means y equals negative 6. So when x was 0, y is negative 6. And that's all the way down here. And we can reflect, right? So we have off of our vertex is our axis of symmetry. And we can reflect our point across it. So if I can go 1, 2 here, I can go 1, 2 here and reflect across. I'm going to show you one more thing, which is sometimes we can find zeros on our graph as well using this. And essentially it's the same idea. It's now if y was 0. So we figured out over here, if x was 0, what happens to y? But we can also figure if y is 0, what happens to x? So I'm going to take my equation, I'm going to replace y up here, I'm going to write it down here, and I'm going to replace it with 0. So I'm going to say 0 equals, and I'm going to write the rest of my equation out. Negative 2 times x minus 2 squared plus 2. And now we're going to solve for x. So we need to get x by itself. We'll see if I have enough room to work here. In order to get x by itself, the first thing that I have to take care of, and I'm going to highlight this in orange, is it's inside these parentheses here. So I need to get this whole thing by itself. That whole thing in orange, I need to get everything that's outside of it. So I need to get rid of this negative 2, I need to get rid of this squared, and I need to get rid of this 2. I need to get rid of all of those things so that I can get this, my orange piece, by itself. And once that's alone, then I can take care of this 2 to get x by itself. So we are going to, just like if this was a two-step equation, if I had 0 equals negative 2 times x plus 2, so just think about like if my orange was there, I would get rid of this plus 2 first. So I'm going to get rid of this plus 2 first by subtracting it to both sides. I would do the same thing here too, right? And this is just an example down here. So I'm going to get rid of that. But it is kind of the same idea that we are getting our orange by itself, and it's really a two-step equation, or two-step, you'll see it's a three-step. But so I'm going to rewrite this. I subtracted this 2, that cancels out, so negative 2 equals negative 2 times x minus 2 squared. I'm now going to get rid of this negative 2 that's multiplying, and I get rid of multiplying by dividing. 1 equals x minus 2 quantity squared. Call that quantity squared because it's a group. Okay, so this is new now. The first two steps, those are the same two steps that we would do in any two-step equation. We would get rid of what's adding and subtracting, and then we'd get rid of what's multiplying or dividing. This piece here is new. This means it's to the second power. And we get rid of a power, especially a second power, by taking the root. So if we had a second power, we get rid of it by taking the square root. So I'm going to show you what that looks like. If I were to take the square root here, it's going to cancel with that 2. The same way that dividing cancels multiplying. The same way that adding cancels subtracting. A square root cancels a square. But if I do that to this side, I also have to do it over here. And here's the thing in an equation. When we take the square root in an equation, there is a positive and a negative value. So the square root of 1 is positive 1. It's also negative 1. Because positive 1 times positive 1 is 1. But negative 1 times negative 1 is also 1. So it could be either one of those values. So positive or negative 1 equals x minus 2. I'm going to rewrite that over here this way. And I'm going to write my x minus 2 first because I'm used to seeing it that way. It could equal a positive 1. X minus 2 could also equal a negative 1. Positive or negative 1. And now we can solve each. So if I add 2 here, x could equal 3. So when y was 0, x equals 3. I can also add 2 down here. And when y was 0, x equals 1. So I have 2 answers here. I got x equals 3 and x equals 1. Let's see what that looks like on the graph. So when y was 0, I'm going to do this in orange since that's the color highlighted, x equals 3, which would be here, and x equals 1. Well, doesn't that make sense with my parabola that I had? So that's just some more information we're able to find on our parabola. Now sometimes we won't have perfect zeros, but I want us to be comfortable with doing that. So here's what we're going to do. I'm just going to solve like maybe a couple, maybe like 3 of these, 2 to 3. We'll see. I may solve 4 and then cut them when I upload this, based on how much time it took, because I don't want to take too much of your time this morning. But let's practice finding the zeros from vertex form. So if we are finding the zeros, there are other things in vertex form we can tell. We know that this is the our vertex is -2, -1. There are some other things we can tell. We can talk about the transformation and kind of what's happening. But I want to focus on solving the zeros. So that means if we made y 0, what would x be? So I'm going to take us through that same process. We are trying to get this thing by itself first, which means I need to get rid of, I'm going to color coordinate some things, that -1. I need to get rid of this negative out front here, and I need to get rid of this too. And this is the order we're going to do it. We're going to take care of the green first, then we're going to take care of the blue, then we're going to take care of the purple. So let's take care of our green first by adding 1 to both sides. So 0 plus 1 is 1. Okay, so green taken care of. Now we need to take care of our blue. So I'm going to recolor coordinate here just so that we have it. That's what I'm trying to get by itself in red. So if I get rid of a negative that's multiplying, so this negative out front is multiplying, it's a -1. I'm going to divide -1 to both sides. So 1 divided by -1 is -1 equals x plus 2 quantity squared. So there's something special going on here. There's some subtleties and things that we're just gonna probably see these over the next couple classes, so that you learn and get familiar with them. But the next thing we have to take care of in this process is we have to get rid of this 2. And the way that we get rid of a squared is we take the square root of both sides. So those would cancel out to give us just x plus 2. Now here's the problem. We cannot take the square root of a negative number. So if you end up with a square root and there's a negative there, that means there's no zeros. There's no solution. And really what that means is on our graph, and this is opening down, so I'm just going to give us kind of a graph here. The zeros go through the x-axis right here. With this graph, left 2, down 1, we would have a parabola here, and it's going to open like this. So there are no zeros. Look, it's not going through our x-axis, so there are no zeros. Let's look at number 2. And again, we're just solving through the process, we have, if we replace that with 0, let's see what happens. X minus 4 squared plus 2. So I'm going to start by getting rid of my 2. 0 minus 2 is negative 2. Oops. We will divide negative 1 to both sides to get rid of that negative sign. Right? Negative and negative cancel out. So negative 2 divided by negative 1 is a positive 2 equals x minus 4 squared. Okay, the way we get rid of a second power, or to the second power, is we take the square root. So those go away, but we also have to do it here. So 2 is positive, so we know that this does go through our x-axis. But it's not a perfect square. We can't take the square root of 2 perfectly. So I'm going to leave it as plus or minus square root 2 equals x minus 4. And then in order to get x by itself, we're going to add 4 to both sides. So we're going to leave our answer in kind of a funny form. I'm going to rewrite it over here. We got x by itself equals 4 plus or minus square root 2. So for this one, there's not really like a good clean 0 on our graph. And we may see that as a trend here. In fact, I'm going to jump to trying to find one that would work out to give us a pretty clean. Number 5 should work. Okay, this will be our last one. Just to give you an idea of kind of how it works as we refine it. 0 equals and then we are going to solve this by subtracting 2 to both sides. So negative 2 equals we can divide negative 2 here so that 1 equals x plus 2 quantity squared, and we get rid of a squared by taking the square root. So if I take the square root there, the square root of 1 is 1, but because it's an equation, we're going to say it's plus or minus 1. Positive or negative 1 would work for that. These guys cancel out so that x plus 2 is plus or minus 1. So I'm going to rewrite that as x plus 2 equals positive 1. X plus 2 equals negative 1. I think this is our example from earlier. Oh no, it's not. So x could equal negative 1. That would be one of our zeros. Our other 0 is x could equal negative 3. So I know it's kind of confusing. I just wanted to show you that there is a way to solve these equations, to find the zeros from vertex form. We know how to do it in standard form using the big X, and it's also possible to do it in vertex form. So we'll continue practicing and just kind of seeing how these graph and work out, and wrap up our unit on quadratics in probably within the week. So hope this finds you well, and take care.